Hello students, welcome to this lecture in which we're going to talk about divergence and curl of the field. And this again comes from the fluid flow, and the words themselves also come from the fluid flow studies. What is the curl and divergence? Divergence relates to the way in which fluid flows towards and or away from a point. This is divergence and curl. It's from the name we can understand how the fluid curls, right? So curl relates to the rotational properties of the fluid at a point. Okay, so let's define both of these properties of the fluid flow. So first one, we're going to define divergence. We'll say that if the vector field at x, y, and z is given by x, y, and z for the x component, and g function for the j component, and h function for the k component, then we define the divergence of f Sorry for the technical issues, but let's continue on. So we have a divergence of f written as divergence of f, and we define it to be the function given by divergence of f is equal to partial of f with respect to x plus partial of g with respect to y plus partial of h with respect to z. And another definition that we're going to give here is the curl. And basically, if this is our function for the field, then we define the curl the curl of f written as curl of f and we define it to be the function I said the function, that's a mistake, to be the vector field given by the following formula. Curl of f is equal to partial of h with respect to y minus partial of g with respect to z for the I component plus partial of f with respect to z minus partial of h with respect to x for the j component, and for the k component we have partial of g with respect to x minus the partial of f with respect to y. And so one observation that we should give over here is that even though we define the curl and divergence that depend on the point, but it can be proven that it doesn't really matter which coordinate system you choose, you will get the same curl and the same divergence, right? So it's independent of the coordinate system. So any convenient coordinate system would give you the same answer. Another thing that for the curl, you see this formula is kind of hard to memorize, so we can think of this formula for the curl as that curl can be thought of as the determinant of the following matrix. If you use I, j, k on top, and here we can put dx, dy, and dz, and on the bottom we put f, g, and h, and we calculate determinant of this matrix. As you can see here, we think of this as an operator, and we'll come back to it in a little bit and talk what do we mean by this in a little bit more detail. So basically what we think of dx g, that would mean dg dx. That's all. So it's like an operator. All right, so let's look at the example. The example tells us to calculate divergence and curl for the following vector field. Find the divergence and the curl of the vector field f of x, y, and z is given by x squared y I plus 2y cubed times zj plus 3zk. Okay, so let's do this out. So for the divergence, this is an easier one to calculate it. We just calculate the partial with respect to x of this part, and we add the partial with respect to y of this part, and we add the partial with respect to z of this part here. So what do we get as an answer? We get 2xy plus 6y squared plus 3. That's the divergence of f for this vector field. And to calculate the curl, we can think of it as a determinant of the matrix, unless we want to memorize this long formula. And in the matrix, we put I, j, and k. And we put over here, we put the partial with respect to x, the partial with respect to y, and partial with respect to z of x squared y, the first component, 2y cubed the second, and 3z is the third. And so we're going to get so what are we going to get? We're going to get, we cross out I, so it's going to be partial with respect to y, partial with respect to y of 3z minus the partial with respect to z of 2y cubed I minus, and then we cross out j, so it's a partial with respect to x of 3z minus the partial with respect to partial with respect to z of 2y cubed. Sorry, I said 2y cubed, that meant x squared y, sorry, times j plus, for k we have the partial with respect to x of 2y cubed minus the partial with respect to y of x squared y k. Right. All right. So when we calculate it, what is the partial with respect to y? So it's going to be 0, and did I make a small mistake here? Let's check. Yeah, I made a small mistake here. I forgot to rewrite z here. Should be z. This should be z, and this should be z. So over here we'll have 2y cubed z and 2y cubed z. All right. So fixed it, so we'll get what? We'll get 0, negative 2y cubed. So negative 2y cubed I. For the second one, this part is 0, and this part is 0, so no j component. Then we have derivatives. This one is 0, and this one will give us negative 2xy. No, sorry, negative x squared, sorry, negative x squared k. And the last discussion is about the using operators instead of derivatives. So gradient as an operator, and we had this discussion during our meeting, but So let's try to think how we can use gradient as an operator. So we can think of gradient like this. We can think of the partial with respect to xi plus the partial with respect to yj plus the partial with respect to zk. And basically, if we have a function phi that is the function of x, y, and z, is a function then we can think of gradient of phi as d phi dx I plus d phi dyj plus d phi dk k. All right. So if we think of this idea and we think about gradient as del operator, sometimes people call it this, let's call it formula star. All right. And then we can think about vector field. We can express the divergence. We can express the divergence of a vector field f given by f for x component plus g for the j component plus h for the k component as divergence of f equal to gradient dot f, which is df dx plus df dg plus df dz. Right, so if we think of gradient as an operator, we can write gradient dot f. And we can express curl as curl of f equal to gradient cross f. All right, so this would be our determinant of this matrix for I, j, and k. So gradient with this gradient we can write as d dx, d dy, d dz, and f is just f, g, and h. And that concludes this lecture, and I'll see you in the next one.